let's take a look now at the idea of producing a closed loop transfer function. Seeing here you have the basic loop, just like you see in this example here. So I'll go through this explanation here on my notes here. So you have G of S, this is your output, and the feedback loop here, this is your feedback, you would say transfer function on the for the feedback signal. Okay, so if you want to find out the closed loop transfer function, you'll be reducing it to this. You'll have a block which is the closed loop transfer function. This would be your output and this would be your input. So let's take a closer look at what happens inside this loop so that we can actually find out the relationship between the output and the input when we have this feedback loop. So the output is really the error here multiplied by G of S, right? And the error in turn is the signal here, the input here, minus this one times this block. So let's write error of S is R of S minus output times H of S. And if we have these two equations, this and this one, then obviously you will be able to have we have those two. Hold on for a second. Then you see the output of S is R of S minus output times H of S times G of S. And then if we move this term to this side, we have output of S is 1 plus GS times H of S equals to R of S times G of S. From here, let's solve for the output. And this expression is my closed loop transfer function. So whenever you have this kind of question, when you have a feedback loop, let's try to find out the transfer function. So what I would do is this. Let's go to MATLAB. I think we have MATLAB here at our disposal. And let's move it over here. And then on this side we can operate. I'm gonna get myself out of there. This is let's define first what G is, yeah? So G in this particular case, well, we have defined S as a transfer function variable before that. Okay, like this, it is a transfer function. If you don't remember that, let's do it over. So S is equal to a transfer function element like this, S, and then, so whenever we type S, the computer knows it's a transfer function element. So G is going to be equal to 100 and then divided by, and then you'll have parentheses here to make sure we have this right, S multiplied by S plus 10, like this, and this is going to be your transfer function, which now we have a little slight problem. Oh, we need a parenthesis. Okay, yes, I did. So that's the G. H is going to be equal to 1 divided by parentheses, and that is s plus 5, like that. Yeah. Here now comes the application of what we just learned about the closed loop transfer function based on this explanation. So the transfer function, the closed loop transfer function now, I think I'm going to put it closed loop TF. Closed loop G. How about that? It's going to be equal to what? We will have now G as the numerator and divided by 1. Now we need to put parentheses to make sure, plus G times H, like this. And lo and behold, we have our closed loop transfer function. Huh? Pretty nice. We got, and here we can do the test for the state error, which would be a step of the G, like that. Yeah. And this would be the step response to the closed loop transfer function. In this case, when you have this kind of loop. If you modify the forward loop, the numerator, with a proportional control, let's say we put a gain of 100, let's say here, right here. Oh no, we do have it, 1 over 100. I think what the idea would be here is, so we do have proportional control. We don't need to add to it, but if we were to put another block over here, all we would have to do is multiply the transfer function of that block by this one, and then we would have a new overall closed loop transfer function. Do you see what I mean? I think just for the sake of example, I am going to introduce, let's say, a derivative controller plus a proportional control. Let's just do it, because that way it illustrates this concept of an overall transfer function. What I'm trying to say is, right here in the forward loop, I am going to put the, let's see, I'm going to enter it here. I need to get my to be able to write here. Okay, so let's say that I introduce a control loop, controller here, a little controller in here that has, I'm gonna put a 10 for proportional control, plus, let's just do S, like that. Okay, so this little block is going to go in here, and now we would have a whole entire system, different system. We would have a system like this with the block I just introduced, plus the original block, which would be my G of S block. Then this is your output, like this, And then you have the input, excuse me, the feedback, which would be the H of S. Yeah? Question, big question. Find closed loop transfer function. Okay, so what I'm trying to say here is now, this was G, right, in my MATLAB here. We're going to call it G3, or G1 is good, right? Let's call it G1 for this one. And this G1 is going to be my 10 plus S. Very good. So let's just keep it here. And I am going to go over here, and remember I already defined what G was. There it is. I know what H is. There it is. What I don't have is my G1 is equal to, in parentheses, what did I say? 10 plus S, like this. Yeah? And then I say, okay, that's my new transfer function for this controller that I want. So now, you see, the numerator is going to have a new G, right? I'm almost tempted to write the word new G equals to G1 times G. Yeah? All right? So now the overall transfer function, the closed loop transfer function, is going to be, so what do we say? Closed loop TF, closed loop TF, let's call it 1 because it's a new one compared to what we were doing before, right? This G is going to be new G divided by what? Don't lose track of what you're doing. 1 plus GH, but G is new G multiplied by, we defined it, was it H? Yeah, H. And lo and behold, in one sweep step, I have a new closed loop transfer function, including the control system there. And if I want to test what this guy does, I am going to say step of the closed loop transfer function 1, and this is my answer now. You see, obviously this one has a very different response to what we had before, but this is how you test now the overall transfer function by knowing this very simple concept here of the closed loop transfer function originally. So if you were to put a different kind of controller, at this point I could test integral control or PID or whatever. It will follow the same procedure as you see here on the right hand side.